Hello and Assalamualaikum everyone. So today I will be explaining about proofreading mechanism in chapter 8. Okay, what is proofreading? So the definition of proofreading is it is a function of the enzyme DNA polymerase which catalyzes the replication process. This enzyme identifies and excises, meaning that it removes the mismatched pieces at the end of the growing strand, leaving the end free to accept the correct nucleotide instead, thereby restoring the correct complementary base sequence. And if the polymerase detects that a wrong or the incorrectly paired nucleotide has been added, it will remove and replace the nucleotide right away before continuing with DNA synthesis. So basically, proofreading is when the DNA polymerase will check whether the new base has correctly paired with the template strand. So it will identify whether it is right or wrong, and then if it is wrongly paired, it will replace the mismatched nucleotide with the correct one. So the DNA will be complete and in correct base sequences. The repair processes of damaged DNA. DNA double helix is unwound so that the DNA polymerase can use the parental strand of DNA as a template or the recipe to figure out what sequence the new strand should have. So it adds in nucleotides one by one. The DNA polymerase adds the nucleotides one by one. It puts the nucleotide that can base pair to the nucleotide across from it, the new one, and with the parent one, with the parental strand. For example, if there's an A adenine in the parental strand, the DNA polymerase will put in a T for thymine across from it, so it is in a correct pair. But sometimes it puts in the wrong nucleotide and then keeps going. This mismatched base pair causes a point mutation, which you can think of as a typo in the DNA sequence of the new strand. So when this happens, the polymerase will identify and will replace the damaged bases, the wrong pair, with the correct one. Okay, how can protein tell who's right? So how can the enzyme, the DNA polymerase, tells when two bases are mispaired together, which one should be removed and repaired? So there are two for bacteria and for eukaryotes. For bacteria, they are original and the newly strand can be differentiated by a methylation state. Okay, what does it mean? Okay, for all DNA strand, it has a methyl group attached to some of its bases. And then the newly made DNA do not have methyl group on it. So that's how the DNA polymerase can identify whether to repair on the parental strand or on the new DNA strand. So the presence or the absence of the methyl group on the base of the nucleotide, it will tell whether which one should be repaired, which one should be replaced, which bases should be replaced with the correct one. And then for eukaryotes, the recognition of nicked single-stranded breaks on newly synthesized DNA. Okay, for this picture, as you can see, on the upper part is the new DNA, is the new DNA strand, and the lower part is the template strand or the parental strand. So as you can see on the template, the base on the template is T for thymines, but DNA is supposedly to be paired together with A with adenine, but here the base on the new DNA is G for guanine, so these two are mismatched. The bases are mismatched. So when this happens, DNA polymerase will detect the mispaired nucleotides. So the new DNA strand is cut and the mispaired nucleotide and its neighbors are removed. And then there will be some gaps, or some gaps within the nucleotides. So a new replacement of DNA will be done, as the missing patch will be replaced with the correct nucleotides by the DNA polymerase. So when this done, when the gap is filled in with the correct base with the correct nucleotides, the DNA ligase seals the gap in the DNA backbone. This is the explanation. When a group of protein recognizes and binds the impaired bases, and then the second complex cuts the DNA near the mismatch, and more enzymes chop out the incorrect nucleotide and surrounding patch of DNA. Surrounding patch of DNA meaning the neighbor, the base, and also the neighbors of the base. And then a DNA polymerase then replaces the missing section with the correct nucleotides, and then an enzyme called DNA ligase seals the gap. Okay, next, the three mechanisms of proofreading. The first one is the instability of mismatched pairs. Second, DNA polymerase is unable to catalyze bond formation of mismatched pairs. And the third one, the function of polymerase DNA to identify and remove mismatched nucleotide. And then the enzyme uses a 3' to 5' exonuclease activity to digest the newly made strand until the mismatched nucleotide is removed. So for the first, these three mechanisms are important for the proofreading to be carried out. So when these three happen during the DNA replication, during the process, proofreading will take place. So the instability of mismatched pair, when these bases are wrongly paired together, they will become unstable, meaning the pair are not compatible with each other, and then this will lead to mutation. So when the DNA polymerase is unable to catalyze bond, so when this happens, lead to mutation, and also any process cannot be carried out when mismatch of base of nucleotides happen. So then this is when the polymerase DNA take place, which is the function to identify and replace the mismatched pairs with the correct one. And then it uses a 3' to 5' exonuclease activity that I will show in the next slide. This one. As you can see in the first picture, mismatch causes the DNA polymerase to pause, leaving mismatched nucleus near the 3' end. Here, the thymine on the parental strand is supposed to be paired with base thymine with adenine A, but here it being matched with C, cytosine. And then when this happens, the pair will be and will enter the 3' end, enters nucleus site, hexonucleus site here. Here. And then when it enters the 3' end enters the exonucleus site. When it enters, the strand is digested in the 3' to 5' direction until the incorrect nucleotide is removed. Okay, then you can see here the incorrect nucleotide is removed and will be replaced with the correct one. So this is how proofreading mechanism works. The role of so basically this topic is about the role of the DNA polymerase, how proofreading works in replacing and how in replacing the correct bases. So this Okay, I think I am done with my presentation. As mentioned, I hope all of you will understand this topic. Okay, thank you. Assalamualaikum and goodbye.